In the first lesson, we learned how to find restrictions or non-permissible values, and we learned how to simplify some fairly simple rational expressions. So what we're going to do today is we're going to actually look at some more complicated rational expressions and how you simplify those. We're not really learning, I guess, anything new. We're still going to find restrictions and we're still going to simplify things, but as I said, we're going to look at some more complicated situations so that you're prepared for as complex type of rational expression as you're going to experience when we learn to add, subtract, multiply, and divide. So what they want us to do is they want us to reduce to lowest terms and they want us to state the restrictions. So remember, the first thing that we have to do is we have to take out a common factor. So if we look at the numerator in this first example, our common factor is t. And we are left with 4t squared minus 9. In the denominator, we also can take out a common factor of t, and we're left with 2t minus 3. Now, there's nothing else we can do to factor the denominator, but we can factor the numerator. We have a difference of squares here. So one of the skills you're going to have to use in rational expressions is being able to look at, have I completely factored everything that's in the numerator and denominator. So you're going to have to look at all your types of factoring. You're going to have to look at difference of squares. You're going to have to look at common factor. You're going to have to look at using box method. If we factor this difference of squares in the numerator, it's going to be 2t minus 3 and 2t plus 3. And in the denominator, we still have a t and a 2t minus 3. So remember, before we actually go ahead and cancel out any common factors, what we have to do is we have to determine our restrictions. So we have two parts of the denominator that we have to look at for determining our restrictions. We have to look at t. So t by itself tells us one of our restrictions is t cannot equal 0. If you take 2t minus 3 and you say it cannot equal 0, and you add 3 to the other side, and you divide by 2, your second restriction is t cannot be equal to 3/2. So now that we've stated our restrictions, we can actually go ahead and we can cancel things. We have a common t in the numerator, which is a factor, so you can cancel it. We have a 2t minus 3 and a 2t minus 3. So our solution to this problem is just 2t plus 3. Now, if we look at the next expression, you're going to have to use box method to factor this. Now, I don't want you to show me all your method of factoring for box method in this question. What I actually want you to do is I want you to use a scrap piece of paper. And on the scrap piece of paper, I want you to factor the numerator and I want you to factor the denominator using box method. Now, you can stop the video right now. Go ahead and try to do that and then start it up again and see what the factors are. So when you factor this in your numerator, you're going to get 2x minus 1 and x plus 3. In your denominator, you're going to get 2x minus 1 and x plus 1. Now, you have to figure out our restrictions. If we look at this first one, x cannot equal negative 1 here if you equate that to 0, and x cannot equal 1/2 if you equate that to 0. If we simplify by canceling out the common terms, the 2x minus 1's cancel out, so our solution, or simplified form of our rational expression, is x plus 3 over x plus 1. If we go ahead and we factor the next question, if you factor the numerator, you get a minus 2 and a plus 4. If you factor the denominator, you get a squared minus 4 and a squared minus 16. And if you look at these denominators, they're both difference of squares. So we can actually factor them some more. A squared minus 4 factors into a minus 2 and a plus 2. A squared minus 16 factors into a plus 4 and a minus 4. So now I can look at my restrictions here. I have negative 2 and positive 2 as restrictions, negative 4 and positive 4 as restrictions. So I can say a does not equal plus and minus 2 and plus and minus 4. There's my restrictions. If I now start canceling out a minus 2's and a plus 4's, everything's canceled out in the numerator, but that means I still have a 1 there. And in my denominator, I have a plus 2 over a minus 4. So there we have it in simplified form. If that example went a little bit fast, rewind the video and watch that example again, how we had to do double factoring here. We had to actually use box method to factor this first expression, and it gave us two difference of squares expressions, and we had to use difference of squares to factor those expressions as well. So let's look at a couple other situations where we're going to have to simplify some rational expressions. If you look at this particular situation here, we've got c minus 4 and we've got 4 minus c. They look almost the same, but they're slightly different. They're actually the reverse of each other. So what we want to do in terms of making these expressions look the same is we actually want to take out a common factor from the denominator. And because the signs are actually switched in the denominator, what we actually want to do is we actually want to take out a common factor of -1 from the denominator. If we take out a common factor of -1, well, negative c divided by -1 gives me positive c, and 4 divided by -1 gives me -4. Now our restriction here is c cannot equal 4. You equate c minus 4 to 0 and you solve for c. Then when we cancel out our common factors, the c minus 4 and the c minus 4, I get 1 divided by -1, which actually gives me an answer of -1. We're going to skip this middle example and we're going to go to the third one. In this particular situation, our numerator is a difference of squares. And when we factor it, we get 1 minus 2x, 2 plus, or 1 minus 2x and 1 plus 2x. When you factor the denominator, when you use box method, you're going to get 3x minus 4 and 2x plus 1 as factors. So now we're going to come up with our restrictions. What can x not equal? Well, if you add 4 and divide by 3, one of your restrictions is 4/3. And if you subtract 1 and divide by 2, another restriction is -1/2. If we now cancel out these common things, 1 plus 2x and 2x plus 1 are identical to each other. So we're left with 1 minus 2x over 3x minus 4 as the simplified form of this rational expression. All right. Sometimes they don't just give you a question, they actually ask you to read some things and simplify some things. So in this case, it says the area of a rectangle is given by this expression. The length is given by that expression. Now they want us to find the width of the field. Well, we know in a rectangle, area is length times width. So if we want to solve for width, we have to take the area divided by the length to give us the width. So if we do that, that gives us 12a squared plus 25a minus 7 divided by 3a plus 7. So there's our expression. Now, the next thing we have to do is we have to factor the numerator. When we factor the numerator in this case, our two factors are going to be 3a plus 7 and 4a minus 1 all over 3a plus 7. Remember, you're going to do this factoring, this box method stuff on a scrap piece of paper. I'm not going to go through factoring. We've done factoring already, so you're going to have to, if you're having trouble knowing where did I get the 3a plus 7 and the 4a minus 1, I've factored that. I've done that on a piece of scrap paper, and then I've brought these factors over. So now if we cancel this out, we find out that the width of the particular rectangle is this expression 4a minus 1. Now it says the perimeter is 54 meters. What's the value of a? Well, we know perimeter is 2 times the length plus 2 times the width. So it says the perimeter is 54. We've got two lengths, which are 3a plus 7, plus two widths, which are 4a minus 1. And we're going to solve for a. We're going to get 54 equals 6a plus 14 plus 8a minus 2. That's going to give us 54 equals 14a plus 12. If we subtract 12 from 54, that's going to give us 42 equals 14a. And if we divide by 14, we get a to be 3. Now it says the cost, the field has to be treated with fertilizer, and the cost is $2.40 per square meter. Calculate the cost. Well, we first of all have to figure out how many square meters there are. Well, the area is defined by this expression. So how I actually find out the area is I now know a is 3. So I can plug a into this expression. 12 times 3 squared plus 25 times 3 minus 7. If you work this all out, you should get the area to be 176 meters squared. Now, we know we've got 176 meters squared, and it costs $2.40 for each square meter. So it's going to cost us $422.40 to actually fertilize this field. So now that we actually have a value, we can plug it in our area and come to a solution. The last couple of examples we're going to look at is where we have expressions that don't just have x's in them, they have x's and y's. Now, you cannot determine restrictions very easily when you have x's and y's. What you do is you say x minus y cannot equal 0, and you isolate either the x or the y. Well, I'm going to add y to the other side. So basically what we know is that x can never be equal to y, or we're going to get a problem here. These two factors are different, so I can't simplify that expression anymore. That's all I get. In the second case, we're going to factor things first of all. There's nothing to factor in the numerator, but in the denominator we have a difference of squares, which gives us x minus 5y and x plus 5y. Okay, so now if we go to determine restrictions, what we're going to do is we are going to, in this case, first of all, isolate or cancel anything that we can. So the x plus 5y's cancel out, and we get 1 over x minus 5y. If you equate this to 0, x minus 5y cannot equal 0, and if you move 5y to the other side, your restriction is that x can never be equal to 5y. So there we go. Some more complicated types of rational expressions, but we're still factoring, determining restrictions, and then simplifying.